Imagine this: a faint radio pulse, weaker than the flicker of a candle on the moon, travels across a yawning void, 15 billion miles of cold, silent space. After nearly a full day, it reaches Earth, where one of 3 giant antennas of NASA's Deep Space Network, each the size of a 20-story building, is listening intently. That whisper is from Voyager 1, the most distant object humanity has ever sent into the cosmos. Launched on September 5, 1977, Voyager 1 was never designed to leave the solar system, at least not alive. It was originally meant to be a planetary explorer, a robotic ambassador to Jupiter and Saturn. But it had other plans. Gravity assists from the giant planets slingshotted it to unimaginable speeds, allowing it to break free from the sun's gravitational leash. It's been running ever since. But what's truly miraculous is that we're still in touch with it. Over 47 years later, Voyager 1 is still speaking to us. Its signal, just 22 watts, about the power of a refrigerator bulb, arrives at Earth as a whisper 1 billion times fainter than the minimum needed for a cell phone call. And yet we hear it. How is this possible? At the heart of this celestial feat is the Deep Space Network, DSN, with its 3 main nodes in California, Madrid, and Canberra. These locations are spaced roughly 120 degrees apart around the globe to ensure constant line-of-sight communication with deep space missions. Their massive 70-meter, 230-foot dishes detect Voyager 1's almost ghost-like signals and convert them into data, making the nearly impossible routine. Voyager's communications are governed by the inverse square law. As the signal travels, its strength drops off with the square of the distance. The signal we receive is less than a quadrillionth of a watt, so faint it would be lost in noise without the DSN's advanced receivers and years of engineering refinements. What is it still doing out there? Today, Voyager 1 is beyond the heliosphere, the bubble of solar winds surrounding our planetary system, and is swimming in true interstellar space. Only a few instruments remain powered, those that measure cosmic rays, magnetic fields, and plasma. With these, it's sampling the never-before-touched medium between stars. In 1990, as it drifted past the orbit of Neptune, Voyager 1 took its final image, a family portrait of the solar system. In that photo, Earth appears as a pale blue dot suspended in a sunbeam. Carl Sagan famously reflected on that image, reminding us that everyone you love, everyone you know, everyone you ever heard of, lived on that dot. Shortly after that iconic photo, its camera was shut down forever to conserve power. The spacecraft no longer sees, but it still listens and whispers back. How does it survive in the darkness? Unlike most satellites today, Voyager doesn't use solar panels. Sunlight is far too weak out there. Instead, it relies on radioisotope thermoelectric generators, RTGs, which convert the heat from decaying plutonium-238 into electricity. At launch, it produced about 470 watts. Now, it's below 200 watts and continues to fall. To adapt, NASA has progressively shut down non-essential systems. Only the most crucial instruments remain, and even those will go dark one by one. Eventually, sometime around 2030, there will be no science data at all. Just a weak beacon indicating its presence, a final heartbeat echoing across the stars. But it hasn't been all smooth sailing. In 2023, Voyager 2 briefly lost contact after drifting just 2 degrees off course, an error that, at 12 billion miles away, was enough to sever its link. Thanks to pre-programmed commands, it self-corrected and restored communications. Voyager 1 has had its share of scares too. In 2022, it began sending corrupted data from its attitude articulation and control system. Engineers traced the problem to a faulty computer and rerouted the data, restoring functionality. In another case, NASA extended thruster life by altering software to use longer, less frequent pulses, buying perhaps 5 more years of control over orientation. These fixes show just how resilient the mission has become. A 1970s spacecraft, running on 8-track-era computers with less memory than a smartwatch, is being kept alive with 21st-century ingenuity and love. What lies ahead? Eventually, Voyager 1 will go silent. Its RTGs will die, its instruments will freeze, and its voice will vanish into the static. But it will keep going, sailing through the Milky Way at 38,000 Mach. In 40,000 years, it will pass within 1.6 light-years of another star. Maybe, just maybe, some distant intelligence will find it and decode the golden record bolted to its side, containing sounds and images from Earth. That idea, the golden record, was a gesture of hope. It contains greetings in 55 languages, images of life on Earth, and music from Bach to Chuck Berry. It is, in essence, humanity's business card to the galaxy. Because Voyager 1 is proof that we can reach beyond ourselves, that even with limited tools, determination, and a vision of the stars, we can push into the unknown. It's not just a spacecraft, it's a message in a bottle, cast into a cosmic ocean, waiting for someone or something to find it. Until then, each time NASA receives that faint whisper, we are reminded, we are still out there. And for now at least, the silence hasn't claimed us yet.